Hello, this is a Poisson process question. It is this Poisson process can describe things like arrivals in a queue, points in space, points on a line, the rate of earthquakes, calls on a telephone line. In this case, the Poisson process. A Poisson process where Px of t equals n equals Pn of t. This means that there will be n occurrences by time t, and it can be written in shorthand like this: n is the number, if it was queues, n is the number of arrivals, and t is the time by which they arrive. You want to show that this is completely specified by the following conditions. 1. The probability that exactly one event occurs in a small time interval t to t plus delta t is lambda delta t plus little o delta t. Lambda is, if it was the arrivals at a queue, lambda is the arrivals rate, and delta t is the time in question. Little o delta t is a function of delta t, where little o means a very small order of magnitude. It is so small that you can combine linear amounts of little o, so 2 little o plus 3 little o still equals just little o. And also, as delta t tends to 0, little o will be 0. Little o delta t becomes 0 before delta t becomes 0. And 2, the probability that 2 or more events occur in a small time interval t to t plus delta t is little o delta t, i.e. it is a very rare event. We don't expect it to happen at all. We don't expect more than one event to happen in the small time interval delta t. In fact, we designed delta t to try to ensure that only one event occurs at a time. The occurrence of events after time t is independent of events before time t. This is also called the memoryless property. And basically, if we have two separate probabilities, then we can multiply them because they are independent. Okay, outline how these three conditions are used to derive the difference equations. So the first difference equation is P0 of t plus delta t. This means that probability that no events will happen by time t plus delta t is equal to the probability that no events happen by time t multiplied by 1 minus lambda delta t plus little o delta t. And the second difference equation, the probability that n events happen by time t plus delta t is equal to the probability that n events happen by time t multiplied by 1 minus lambda delta t plus Pn minus 1 of t times lambda delta t plus little o delta t. So it's worth noting here that this here could be related to the law of total probabilities because we have a 1 minus situation. Here, because we have pluses, it's like this is the first situation or the second situation or the third situation, because in mathematics, if you have a plus in probability, it means or in English. So I'll just go through the first part, P0 of t plus delta t. It is, so basically the probability that no events will happen by time t plus delta t is equal to the probability that no events will occur by time t and the probability that no events will occur by time t will occur in time t to t plus delta t in that small time interval. So the probability that no events occur by time t is easily written as P0 of t, and that means multiply. So we're basically multiplying these two, and then the probability that no events occur by time in a small time interval t to t plus delta t is the same as 1 minus the probability that one event or more events occur in a small time interval. So the probability that no events occur by time t is multiplied by 1 minus this, the probability that one event, that comes from condition 1, that one event will occur, or that's plus more than one event occur, that comes from condition 2. And we multiply them, and that comes from condition 3. So then we have the probability that no events occur by time t multiplied by 1 minus lambda delta t, which is the probability of one event occurring, or O delta t, little o delta t, the probability of more than one event occurring. And that's that part done. Okay, for the second part, I'll just write out this probability, Pn of t. So we have Pn of t plus delta t. That is the probability that n events will happen or occur by time t plus delta t. That is equal to the probability that n events occur by time t multiplied by 1 minus lambda delta t plus the probability of n minus 1 events occurring by time t times lambda delta t plus little o delta t. Okay, so let's get down to this. Right, so right, we'll do this in words. So the probability that n events will happen by time t plus delta t is equal to the probability that all n events occur by time t and the probability that no events occur in the small time interval t to t plus delta t. Okay, and then or, because that can happen, that all n events occur by time t, the other situation is that n minus 1 events occur by time t, and that leaves one more event, md, and the probability that one event occurs in the time interval, in the small time interval t to t plus delta t. Or there's another situation, the probability that more than 2 events occur in the small time interval, i.e. that n minus r, where r is greater or equal to 2 events occur by time t, and the probability that 2 or more events occur in the small time interval t to t plus delta t. Okay, so from rule 3, or condition 3, we can multiply. That's from condition 3. From condition 3, we can multiply these. Okay, this here is little o delta t. That is from condition 2, 2 or more events, highly unlikely to occur, a rare occurrence. That's little o delta t, and because this is of such a small order of magnitude, it just overrules this part here. Okay, the probability that n minus 1 events occur by time t, that can be written as the probability of n minus 1 by time t, and multiply by the probability that one event will occur, that is lambda delta t. Now you can look up here and you can see this is this one, Pn minus 1 of t, and it's multiplied by lambda delta t. I mean, we could add in plus little o delta t as the rest of condition 1 says, but basically we're going to put the little o delta t on at the end here anyway. Right, so that's that. And then the first one, the probability that n events occur by time t, that is Pn of t. And then multiply by that no events occur, that is 1 minus the probability of 1 or more events, so that's the probability of one event, lambda delta t, or more events plus little o delta t. Okay, so if we put these all together now, we're going to have the probability that n events occur by time t plus delta t is equal to the probability that all n events occur by time t multiplied by the probability that no events, or 1 minus 1 or more events, occur. And we'll leave a little o delta t here to the end like Patty does, right? So we'll just do that. And then plus the probability that n minus 1 events occur by time t, and one event, which is lambda delta t, occurs in the small time interval t to t plus delta t. And then the third situation, so every time I write or, say or, I'm writing plus, and then the third situation, the 2 or more events, that's just little o delta t. And that's that.